All right, guys. What we're doing today is finishing the note sheet from yesterday. We are finishing the note sheet from yesterday. Are there any questions on the homework assignment so far? Any questions over the homework before we get started? So this here is the problem that we're starting on. We finished with the one before it. So we're going to get started with this one here. So we want to find the value of the variable. So for this one here, we're trying to find the value of y. Now this angle here, these two here are vertical, but this angle is going to equal half the sum of the two arcs that it's connected to. So that would be y plus 95. However, we do need to figure out one of those two angles. Now we know that this angle and 102 degrees do make a straight line, so they add together to be 180. So we can take 180 and minus 102 from it. 10, 8. So this is 78 degrees. So 78 degrees is equal to 1/2 of y plus 95. Now at this point here, we could distribute the 1/2 with y, or we can multiply the whole thing by 2. And the reason we do this is because on the right-hand side, 2 times 1/2 is 1, leaving us with just 1 times not y plus 95, or just y plus 95. On the other side, 2 times 78 is 156. Last but not least, we need to subtract 95 from both sides, telling us y is 61 degrees. That's it. Questions on this here? We're looking at the last one of these two types. Now they told us our angle is 30 degrees, is equal to 1/2 of, now since the two lines intersect outside the circle, we are subtracting the bigger arc from the smaller arc. Which one would be bigger, A or 44? A, because it is farther away. The arc that is farther away from the angle will be the bigger of the two. So we have A minus 44. Because if it intersects outside the circle, we are subtracting the two arcs. If it's inside the circle, we add the two arcs together. And again, just like the last one, we can multiply both sides by 2, telling us that 60 degrees is equal to A minus 44. And at this point here, we would add 44. And A would indeed be 104 degrees. Any questions on any of this here? Are we good with this here? Circumscribed angle is an angle whose sides are tangent to a circle. And the measure of a circumscribed angle is equal to 180 degrees minus the measure of the central angle that intercepts the same arc. So these two lines are tangent, so they do make 90 degrees. Now the reason I say that is because it is a four-sided figure. Any four-sided figure's sum, interior angles, should add together to be 360. If we know that two of them are 90, well, 360 minus 90 is 270. And if we take 90 away from it again, we get 180. So these two angles here should add together to be 180. So if we look at this here, AD and dB are two tangent rays. So it means that x and 135 degrees should add together to be 180. So to find x, so we're saying x plus 135 is 180. And to solve this, we would subtract 135 from both sides, telling us x is 45 degrees. Any questions on any of this here? Is x a central angle? It's an inscribed angle, yes? Now, EGF, this here would be the central angle, yes? So, whatever this measure is, we can call it y. Y and 30 would add together to be 180, yes? Because the central angle, as we just had, the measure of the central angle and the intercepted arc are the same. So this and this here will be add together to be 180. So here, the central angle y and 30 should add together to be 180. So we're saying y plus 30 is 180. And this will make sense where we're going. Now, here we can subtract 30 degrees, telling us y is 150. So what that's telling us is that this central angle should be 150 degrees. Now, that doesn't seem like it's hugely important, but it does tell us one thing. Because if that angle is 150 degrees, what is the measure of arc EF? What is the measure of this arc here? Because the central angle is going to have the same measure as its arc, its connected arc. Or, the theorem actually says it itself, the measure of a circumscribed angle is equal to 180 degrees minus the measure of the central angle that intercepts the same arc. So, that should also be 150. Now, what is actually angle x? Angle x is an inscribed angle. And as we learned at the start of this section, an inscribed angle, x, that's 150, is equal to what? Half the measure of its inscribed arc, intercepted arc. So it's half the measure of EF. Well, what is the measure of EF? So it's half of 150, which is 75. So the measure of angle x is 75. So we had to find the central angle, or really find its arc, to be able to find the value we needed. So this here had another step that we had to go through. Any questions on this here? Inscribed angles is on the circle. It's inscribed. A central angle's vertex is at the center of the circle. So this one here, 124 degrees is a central angle because its vertex is on the center of the circle. So what do we know about x at 124? K equal 180. So x plus 124 degrees is 180. So to solve this here, we would guys, let's focus in. We would subtract 140 degrees from both sides. 56 degrees. And that's it. Questions on any of this here? So, let's look at this one here. Find the value of x. Now, for this one here, we can't necessarily go straight to it, but we can find the inscribed angle and its arc, because 42 degrees and the central angle should add together to be 180. So we can say 180 minus 42, which is 138 degrees. Now, if the central angle is 138 degrees, we know that arc AB here should also be 138 degrees. So we'd have to find half of 138, which is indeed 69 degrees. Questions on this here? So for these here, we really had to find that arc to then find our angle. Yeah. Any questions on any of this here? Are you ready for the next one? Yes. Because here we would do because we know x and 120 add together to be 180. Subtract 120 from 180 and get 60. Now, as we notice with this here, because we can do this just a hair different, we notice that the central angle and its arc have the same measure, yes? So we could say that 50 degrees and this arc should add together to be what? 180. So we could say 180 minus 50 is, so the measure of this arc is, and x is going to be half of, which is indeed 65 degrees. Questions on any of this here? Are you ready for the next one? Now looking at this here, because we have the intersection outside the circle, yes? So 45 is equal to 1/2 of the bigger arc, which in this case would be 15x minus, what is the smaller? And it's not in the nose, so that's fine.
Do we need to draw this?
I would at least follow along so we see kind of how this works. What is the smaller arc?
45.
Well, because it's arc FH, yes? But we don't have a measure for it, do we? What is the whole circle? 360. So I know for certain that whatever that measure is, the whole circle is 360, and if we take whatever 15x is from it, we would have that smaller section, yes? And that's what we would actually need to do to get the other one. So even though it didn't give it to us, if we take 15x's value from 360, we should have that other arc. Does that make sense? Now, it's not so much as it is intuitive to see it that way, but that's how we would approach this. Now, So before I multiply both sides by 2, I want to resolve the other set of parentheses inside this here, because we would need to distribute this negative. It will make the 360 negative, but the negative 15 plus 15x. 15x plus 15x is 30x and 360 both divisible by 2? Yes. So I'm going to do this in 2 ways so we can see it as both. So if we wanted to, one way we can say is I can distribute the 1/2. 1/2 times 30 is 15. Half of 360 is 180. From here, 180 to both sides, telling us that 15x is 225 degrees. And last but not least, we would divide both sides by 15. Minus x is 15. Yes, and that's why I put it to the side. Now, we could have multiplied both sides by 2. Now, if we did that, the 1/2 would cancel, and telling us that the one side is 30x minus 360. But we also have to multiply the other side by 2, which is going to turn it from 45 to 90. Now, at this point here, we can add 360 to both sides, telling us that 30x is equal to 450, yes? And then we would do what? Divide both sides by 30. And x is still 15. So we could do it either way. Now this way, either way here is not too bad, and the only reason that I did show especially the multiply by 1/2 is because 30 and 360 are both divisible by 2. So the numbers work out nicely. If not, if you don't like doing that, we can multiply both sides by 2, and we'll still get to the same answer. Questions on any of this here? We ready for the next slide? Three, 5, 7 through 14.